All right, this is Algebra 2 Year 2, the review worksheet for 11.1, 11.2, and 11.8. So the first section of this review covers 11.1, which was the permutations and combinations section. And looking at number 1, it says, in how many different orders can you line up 8 cards on a table? So this section had more than just permutations and combinations. It also included factorial stuff and the fundamental counting principle. So when you're looking at these questions, you need to think more about not just permutations and combinations, but whether you need to use factorial or whether you need to use the fundamental counting principle. So for number 1, it's saying how many different orders can you line up 8 cards on a table? You're only given one number. So usually if you're only given one number, you're going to want to kind of think factorial. And this, if you think about this question, it's saying if you have 8 cards and you're going to line them up on the table. So you start out with 8 cards. You can choose any of those 8 cards. Once you've laid one down, you have 7 cards left. You can choose any of those 7. You lay another one down, you have 6. And so on until you're out of cards. So you're laying down 8 times 7 times 6. And so on. And that was your factorial. 8 times all of the numbers that came before it equals 8 factorial. So when we find 8 factorial, we get that there are 40,320 different ways you can order these 8 cards on the table. So similarly for number 2, where it says, in how many ways can 12 basketball players be listed in a program? So again, you're going to have 12 to start with, and then once you've listed one, you have 11 and 10 and so on until you get to 1. So this again is 12 factorial. And 12 factorial equals 479,001,600. Number 3. Number 3 says, suppose Ruth Ann has 3 routes she can choose to get from school to the library and 5 routes from the library to her home. How many routes are there from Ruth Ann's school to her home with a stop at the library? So now, in this one, you're given 2 numbers, but they're not really asking you, like they're not giving you a number and saying you're picking this many out of a number. So this one isn't really a permutation or combination either. This one goes back to the fundamental counting principle. So this was like the example that we were given that you have 3 pants and 2 shirts. How many different outfits can you make out of that? So this is the same thing. She's got 3 routes from school to the library, and she's got 5 routes from the library to home. How many different routes can she make? So you're going to take the 3 times the 5, and you get 15 different routes. And then again, similarly for number 4, you're given that a yogurt shop offers 6 different flavors of frozen yogurt and 12 different toppings. How many choices are possible for a single serving of frozen yogurt with 1 topping? So this one says that you have 6 choices for frozen yogurt and 12 choices for toppings. How many different 1 flavor yogurt, 1 topping can you make? How many different possibilities are there? So you're going to take the 6 times the 12, and you get that there are 72 different possibilities. Now this one is very similar to number 5, where it says, at a deli, a sub sandwich can be ordered with any of 7 different condiments. And how many different ways can a sandwich with exactly 3 condiments be ordered? So again, you're picking condiments, but this one is different because you have 7 condiments to start out with, and you're picking 3 of them. Where in number 4, you were picking 1 yogurt and 1 topping. Now you have 7 choices, and you're picking 3 of them. So now is when we need to start thinking whether it's a combination or a permutation. So when we're picking condiments for our sandwich, does order matter or not?
No.
No, order doesn't matter. So was it a permutation or a combination when order mattered? Or when order didn't matter, sorry.
Ms. Lang, doesn't it ask how many different ways 3 condiments can be ordered? So wouldn't that be?
Wouldn't it just be 3?
No, because you're picking exactly 3 condiments to put on your sandwich. You're picking 3 out of the 7. So how many different ways can you pick 3 out of 7? So again, so order doesn't matter. So was that a combination or a permutation? It's a combination. So order does not matter. And that tells you that it's a combination. So we're going to use the C notation, and we know that we have 7 different choices, and we're choosing 3 of them. So you should have a 7 on the left, a 3 on the right. And then on your test, I want you to at least set up the fraction. You don't have to simplify it because I know you can plug this into your calculator, but I want to at least see the fractions set up. So the fraction was 7 factorial over 7 minus 3 factorial times 3 factorial. So as long as you have this set up, you're fine. And then you can put this into your calculator, and you should get 35. So there are 35 different ways to choose 3 condiments. For number 6 through 8 are all, they already tell you if they're a permutation or combination. So you just have to evaluate them. So for number 6, we know that it's a permutation. So again, I'd at least like to see the setup of the fraction. So you're going to have 9 factorial over 9 minus 4 factorial. And again, once you plug that into your calculator, you should get 3,024. Number 7, you don't have to set up the fraction because it's going to give you a complex fraction and it'll just look really confusing. So this can just be plugged into your Inspire using the fraction key, that you'll have this combination over this combination. And you should get, if you leave it in the reduced fraction, you should get 6,044 over 91. Or if you found the decimal answer, it's 75.21. Either one would be acceptable, the fraction or the decimal. For part 8, or for number 8, we have a combination. So again, I'd like to see the setup of the fraction. So you're going to have 7 factorial over 7 minus 6 factorial times 6 factorial. And then once you plug that into your calculator, you should get 7. And number 9. Number 9 says that 8 teams enter a tournament. How many arrangements of first, second, and third place winners are possible? So again, you're given that you have 8 teams, and you're choosing 1, 2, 3 different things. So you want to start thinking again, combination or permutation.
Permutation.
And this one is a permutation because order matters. It matters if you win, or if you are first, second, or third. It makes a difference which place you finish in. So this one, order matters. So this tells you it's a permutation. So again, we're going to use the permutation notation. We have 8 teams, so that goes on the left. We're picking 3, so that goes on the right. And again, setting up the fraction, you have 8 factorial over 8 minus 3 factorial. And plugging that into your calculator, you should get 336. So there are 336 different arrangements for first, second, and third place. So for number 10, we're moving into the probability section, which was 11.2. And number 10 asks, Lynn and Dawn tossed a coin 60 times and got heads 33 times. What is the experimental probability of tossing heads using Lynn and Dawn's results? So remember with probability that for experimental probability, that to find the probability of whatever you're looking for, it's the number of times that the event that you're looking for actually happened over the total number of trials or the total number of experiments that were done. So for number 10, probability of heads equals so the number of times that they got heads, which was your 33, over the total number of trials that they did. So they tossed a coin 60 times. So probability of heads is 33 over 60. Now, you're going to want to reduce this fraction. So you'll get 11 over 20. And if you found the decimal for this, it would be 0.55. And that 0.55 equates to a 55%. That's multiplying this decimal by 100. And you should be able to find the reduced fraction and the percent. Number 11 says a bag contains 6 red marbles, 6 white marbles, and 4 blue marbles. And it wants to find the probability of red or blue, of you picking out a red or a blue marble. So again, you're going to want to find your total number of marbles. So we've got total marbles equals, we have 6 red plus 6 white is 12, plus 4 blue is 16. So we have 16 total marbles. And we want to find the probability of red or blue. So again, the probability on is the number of whatever you have, whatever you're looking for over the total number. So for this one, we have 6 red marbles plus 4 blue marbles over our whole 16, which equals 10 over 16. And again, reducing the fraction, you're going to get 5 over 8. Putting that in decimal form, you're going to get 0.625, which equates to a 62.5%. Again, multiplying your fraction by 100. And on the back, the back says a spinner is numbered from 1 to 10, with each number equally likely to occur. What is the probability of obtaining a number less than 2 in a single spin? So we have numbers 1 through 10 that are possibilities on our spinner. And we're looking for the probability that we can obtain a number less than 2. So probability of less than 2. So how many numbers are possible that are less than 2? Just one. So we have 1 over our entire set, which is 10. So we get our reduced fraction is 1/10. And then if we find the decimal of that, you get 0.1, which equates to a 10%. Again, multiplying that decimal by 100. And number 13 is finding the geometric probability. So this was where we were looking for our target area, and we were putting it over the entire area. So number 13 says, if a dart hits the target at random, what is the probability that it will land in the shaded region? So our target region for this case is the shaded small circle in the middle. And our total region is this whole big circle. So first we should find the area of the shaded region. And I put a reminder that the area of a circle is pi times r squared, r being your radius. So for the shaded circle, we're given that our radius is 3 inches. So we're going to have pi times 3 squared, which equals 9 pi. And you can either leave it as 9 pi or multiply through by the pi. Either one is correct. And then we want to find the area of our entire region, or our total area. So again, we have a circle. So we're looking for the area of the whole circle. And we're given that our radius is 12 for the whole circle. So for this one, we're going to have pi times 12 squared. And that equals 144 pi. So now the probability that it's in the shaded area equals the area of the shaded area, which we found as 9 pi, divided by the area of the entire circle, which was 144 pi. Now we can simplify this fraction, and we should get 1 over 16. And then finding the decimal for that, we get 0.0625, which equates to a 6.25%. Again, multiplying your decimal by 100. Now the final two questions come from 11.8 and expanding the binomials. So I don't care on your test which way you use, if you use Pascal's triangle or the combinations. You can use either one, whichever one you prefer. So which one would you like me to show you? Using Pascal's? Okay, so from Pascal's triangle, we're going to look at the 6th row because we're going to the 6th power. And from the 6th row, we're going to get numbers 1, 6, 15, 20, 15, 6, and 1
Did you get these numbers from?
from Pascal's triangle. So from this one. And it comes from the 6th row. And those are going to be your coefficients for the expansion of this binomial. So you'll multiply each term by the coefficient. So for our first one, our first coefficient is 1. And then we're going to take our first term, which is a. And a starts out at the power that we're taking our whole binomial to, so that's 6. And then we're also multiplying by our second term, which is a b. And the b starts out at a power of 0. Your a exponents are going to decrease, your b exponents are going to increase. This is also an addition binomial, so all of your terms will be added. So we're going to be adding the next term. Your coefficient is 6 multiplied by the a, and remember we're decreasing, so this is a to the 5th. Multiplied by the b is increasing, so it's b to the 1st. Add your next term. Your coefficient is 15. You have a now to the 4th, b squared. Your next term, your coefficient is 20, multiplied by your a, which is to the 3rd now, and b, which is to the 3rd. Your next term is a 15, or your next coefficient is 15. A is squared now, b is to the 4th. Your next coefficient is 6, a to the 1st, b to the 5th. And your final term, the coefficient is 1. You have a to the 0 now, b to the 6th. And remember, your exponents in each term should add up to the power that you're raising your binomial to. So in this case, each of these, when you add the exponent, should equal 6. So now we just need to simplify our expanded version. So for our first term, we have 1 times a to the 6th times b to the 0. b to the 0 is 1, because anything raised to the 0 power is 1. So you have 1 times a to the 6th, which is a to the 6th, plus 6 times a to the 5th, b to the 1st, which is just b. So you have 6a to the 5th b, plus 15a to the 4th b squared, plus 20a cubed b cubed, plus 15a squared b to the 4th, plus 6a to the 1st, which is just a, b to the 5th, so 6a, b to the 5th. And your last term, we have 1 times a to the 0. a to the 0 again is 1, because anything to the 0 power is 1. So you have 1 times b to the 6th, or just b to the 6th. So that is your simplified expanded binomial. And number 15, our last problem. Now this one, the binomial, is a subtraction. So that tells us that our signs in between our terms are going to switch. So we're gonna have minus, plus throughout. So again, using Pascal's triangle, if we look at the fourth row, we're gonna get the numbers 1, 4, 6, 4, 1. So again, those are our coefficients. So our first term, we have 1 times our first part of the binomial, which is c. That'll be raised to the 4th power. And then we're multiplying by our second term, which is the 3. And that's to the 0 power. Now again, because this is a subtraction, our signs are going to alternate. So we have a subtraction. Our next term is 4. Our next coefficient is 4. Multiplied by the c to the 3rd, 3 to the 1st. Our next term is added. Our next coefficient is the 6. And it's c squared, 3 squared. Subtract the next term. Our coefficient is 4. We have c to the 1st, 3 to the 3rd. And then adding our last term, and our coefficient is 1. We have c to the 0 and 3 to the 4th. So again, we need to simplify this expansion. So for our first term, we have 1 times c to the 4th times 3 to the 0. And again, 3 to the 0 is 1. So you have 1 times c to the 4th, or just c to the 4th. And then again, we're bringing down our subtraction sign. And we have 4, and we have 3 to the 1st. So that 3 to the 1st is just 3. So you have 4 times 3 is 12 times c cubed. Bring down the addition sign for our next term. And we have 6 times 3 squared. 3 squared is 9. So we have 6 times 9 is 54 times c squared. Bring down our subtraction sign. Now we have 4 times 3 squared. 3 squared is 27, so we have 27 times 4 gives us 108. And then we have c to the 1st, which is just c. And then bringing down the addition for our last term, we have 1 times c to the 0, which is 1. So we have 1 times 1 times 3 to the 4th, and 3 to the 4th is just 81. So that is our simplified expanded binomial. And again, our coefficients came from Pascal's triangle, but you could just as easily use the combinations. Like I say, either way is fine, as long as you know which way you're doing it. And we're done.